Hello, dear children. In our previous class, we studied about the test for similarity of triangles. We will just revise it and then begin with practice set 1.3. So, test for similarity of triangles. The first test is AAA test for similarity of triangle. That is a angle, angle, angle. That is, if all three angles of two triangles are congruent, then we can say the two triangles are similar. Here, angle A is congruent to angle P, angle B congruent to angle Q, and angle C congruent to angle R. Then triangle ABC is similar to triangle PQR by AAA test for similarity. Please note, even if only two angles are given to be congruent, the third angle is automatically congruent because the sum of the angles of a triangle is always equal to 180 degrees. So the third angle automatically becomes congruent, and so we can call this test even as AA test for similarity. Now, the second test is SSS test for similarity, that is side, side, side. Now, when two triangles are similar, the three sides are proportional. Proportional means they are in the same ratio. Here, PQ upon YZ is equal to QR upon XY is equal to PR upon XZ. Then we can say triangle PQR is similar to triangle Z by X by SSS test for similarity. The third test, which is the last test, side angle side. SAS means side angle side. So here we will have two sides proportional and the included angle is congruent. Here KL upon RS will be 1 upon 1.5. When you reduce it, you will get it to be 2 upon 3. LM upon ST is also equal to 2 upon 3. And here angle L congruent to angle S, which is an included angle. And so we can say triangle KLM is similar to triangle RST by SAS test for similarity. Now we will begin with practice set 1.3. In figure, angle ABC is given to be 75 degrees. Angle EDC is also given to be 75 degrees. State which two triangles are similar and by which test. Also write the similarity of these two triangles by a proper one-to-one correspondence. Now, whenever we write the triangles similarity, you have to take care of the correspondence also. So here we can see angle ABC and angle EDC are 75 degrees both. So that means angle B and angle D are congruent. That also note B corresponds to D. So the position when we write the two triangles have to be the same. So let's write down in triangle CDE and triangle or in triangle ABC and triangle EDC. CDE or and CBA. So we are given these two angles to be congruent. We will write it down. That is, these two angles are congruent. So angle CDE equal to angle CBA equal to 75 degrees congruent equal to given. Therefore, angle CDE congruent to angle CBA. Also, we know that angle C is a common angle for both the triangles. So, we can write that also angle DCE congruent to angle BCA common angle. And therefore, we get two angles to be congruent and therefore we can say the two triangles to be similar by AA test of similarity. Let's move on to the second one. Are the triangles in figure 1.56 similar? If yes, by which test? Now here we can see we are given all three sides for both the triangles. Now we have to find whether they are proportional, that is they are in the same ratio or not. So let's find out PQ upon LM. So we will write down PQ upon LM will be 6 upon 3. When you reduce it, you will get it to be 2 upon 1. Let's put it as 1. Then we'll write QR upon MN. That will be 8 upon 4. When you reduce it, you'll get it to be 2 upon 1. then we'll take PR upon LN. That will be 10 upon 5. When you reduce it, you will get it to be 2 upon 1. Now here you can see all three ratios are equal to 2 upon 1, which means all the three sides are proportional. So we will write in triangle PQR and triangle LMN, PQ upon LM is equal to QR upon MN is equal to PR upon LN. Let's write it down from 1, 2, 3. So what can we say when the three sides are proportional? Yes, the two triangles that is PQR similar to triangle LMN by SSS test of similarity. Let's move on to the third sum. As shown in the figure, two poles of height 8 meters and 4 meters are perpendicular to the ground. If the length of the shadow of smaller pole is due to sunlight is 6 meters, then how long will be the shadow of the bigger pole at the same time? So here we have PR and AC as the poles, QR and BC as the shadows. So now please note the shadows are cast at the same time. So we can say triangle PQR is similar to triangle ABC because their shadows are at the same time. So now we will write down PQR similar to triangle ABC. So whenever two triangles are similar, we can write the corresponding sides, that is PQ upon AB equal to QR upon BC is equal to PR upon AC. Corresponding sides are proportional. Now here, PQ and AB are not at all needed because the values are not given, and so we will not write. Let's substitute the values, cross multiply and get the value of x. So 4 ones are 4 twos are 2 into 6 will become 12. So x is equal to 12. Therefore, according to the question, that is the length of the shadow of the bigger pole will be equal to 12 meters. So this is how we do the third sum. Now we will go to the fourth sum. In figure, in triangle ABC, segment AP perpendicular to BC, BQ perpendicular to AC, B dash P dash C, A dash Q dash C. Then prove that triangle CPA is similar to triangle CQB, AP equal to 7, BQ is 8, BC is 12, find AC. This is a question. Now, here we have to first prove the two triangles to be similar, and then we have to find the value of AC. So to prove this, let us write down given AP perpendicular to BC, BQ perpendicular to AC, B dash P dash C and A dash Q dash C. Now to prove triangle CPA similar to triangle CQB. So we will consider triangle CPA and triangle CQB. Now here you can see when you consider the two triangles, you can see first of all segment AP is perpendicular to segment BC, BQ perpendicular to AC. So these two angles, that is angle APC and angle BQC, are 90 degrees. So that we can write. So each measures 90 degrees. So now here we can see in both the triangles we have angle C to be a common angle. In both the triangles we have angle C, a common angle. So we can write, we can rearrange this and let angle C come in the center. That is angle ACP will be equal to angle BCQ, common angle. Therefore, now we have got the two angles of the two triangles to be congruent, and therefore we can say the two triangles are similar by AA test of similarity. Now we have to find the second part, that is find AC. So let's write the given, and we will take down this triangle CPA similar to triangle CQB. Now we will write the corresponding sides. Corresponding sides are proportional. This is the reason that you will have to write. Now here you can see CP and CQ values are not given, nor it is needed for us to find. So PA value is AP, QB is 8, CA is 12, and CB value is 12, and AC you have to find. So these values are given to us. Now we will take the second and third ratio and substitute the values. Now AC will be 7 into 12 upon 8, and when you reduce it, 4 twos are 4 threes are. So 7 into 3, 21 upon 2. That will be, please divide it and try to get the answer. AC will be equal to 10.5 units. Let's move on to the fifth sum. In trapezium PQRS, side PQ is parallel to side SR, AR is 5AP and AS is 5AQ, then prove that SR is 5PQ. I have put the given, the same thing whatever is here. So let's write to prove SR is equal to 5PQ. So now what we are going to do, we will consider these two triangles. So first of all, please note PQ is parallel to SR. Whenever two sides are parallel, the alternate angles are congruent. So when PQ is parallel to SR, we can say angle PQS congruent to angle RSQ. Alternate angles are congruent. So let's write the proof. Side PQ parallel to side SR given. Therefore, you can see the alternate angles to be congruent, and therefore we will write angle PQS congruent to angle RSQ, alternate angles for the transversal QS. Now, this we have to consider these two triangles, that is PQA and triangle RSA. So we will PQS can also be written as PQA, and angle RSQ can be written as angle RSA because the points Q dash, A dash and S are collinear. So let's write down the reason will be Q dash, A dash, S. Now we will consider the two triangles, that is PAQ and triangle RAS. So we will write down P in triangle PQA and triangle RSA, this point, that is angle PQA congruent to angle RSA given. Now we also can see there are vertically opposite angles, that is angle PAQ congruent to angle RAS. The reason is vertically opposite angles. So the two triangles PQA is similar to triangle RSA by AA test for similarity. Now, whenever the two triangles are similar, we can write the corresponding sides, that is PQ upon RS is equal to QA upon SA is equal to PA upon RA. Now, you can substitute the values. The reason will be corresponding sides are proportional. So now we will substitute the values. Here we are given AR is equal to 5AP and AS is equal to 5AQ. We will substitute the values. That is, we are given this. So let's substitute the value. Now here you can see AP in the numerator, AP in the denominator can get cancelled. Similarly, AQ in the numerator, AQ in the denominator will get cancelled. So you will be left with 1 upon 5 is equal to PQ upon RS. And when you cross multiply, RS is equal to 5 PQ or SR is equal to 5 PQ, and this is what we have to prove. So copy it down. That's all for today. Thank you.